Hello Algebra 1, I just want to give you a little bit of feedback on each classwork starting with 12.1 in this video. And really I'm just going to go through one type of each problem, going through all of the classworks so that it's not too long of a video and so that you have a little bit more insights as to how to finish up your classwork and study for the test. So really it's going to be important that you understand what's happening when you're converting between all forms and what the properties of all forms are. So starting with problem number 1 here, we're asked for the form, the general equation of that form, the type of important points that we can pull from that form, the coordinates of those important points, and whether this function would open up or down. So for number 1, we see that this has 5 parentheses k minus 6 over 5 close parentheses, parentheses k minus 5. Well, that is factored form. What you can get from factored form are your x-intercepts using the zero product property. So if we were using the zero product property, we would take what's in the parentheses, k minus 6 over 5, and k minus 5, and set both of those equations equal to 0 and solve for k. It's essential that you set them equal to 0 and solve for k instead of just taking the opposite of this, because sometimes your coefficient on the variable will not be 1. So if those are my important points, they represent my x-intercepts, which are in the form of the number, comma 0. So for this function, it would be parentheses 6 over 5, comma 0, and parentheses 5, comma 0. The general equation of any factored form equation looks like that. Now, would this open up or down? For that, we just look at the lead coefficient, and that will be the case for every function. Since this lead coefficient is 5, that is greater than 0, it will open up. For problem 2, we actually have a standard form function shown there, which is probably your most familiar form, y equals ax squared plus bx plus c. And the important point that we can get from this function is the y-intercept, which actually is -4. So it's just the c term, the constant term, when in standard form. The important point coordinates reflected of the y-intercept would be 0, -4. And since this lead coefficient is -4 and below 0, this would open down. The last form we're looking at for number 3 is vertex form, and you can get the vertex from looking at that equation by identifying k and h. In order to find h, it's similar to finding the x-intercepts in that you can take what's inside the parentheses, set it equal to 0, and then solve for x. Now h also gives you the value for the axis of symmetry, which is a vertical line with the equation just equal to your input when your output is the vertex. So the general equation of y equals a parentheses x minus h squared plus k is vertex form. Of course, you get your vertex from that, h comma k, and the coordinates for this function would be 3 comma 4. And since our a value is 2, which is greater than 0, this would open up. This is an example of converting from vertex to standard form. You can also think of it in factored form. It's just going to be a similar process. Really, the first thing I want to think about is getting rid of this squared. And really, x plus 2 squared represents x plus 2 times x plus 2. It is not just x plus 2 plus 4, or x squared plus 4. So if I think of it that way, then I can represent this as -3 times x plus 2 times x plus 2 plus 27. And I can distribute this lead coefficient of -3 into both. And when I do that, I get -3x minus 6. And when I said both, I meant both of these two terms inside this first set of parentheses. I don't want to distribute it to the second set, only one at a time. And then from there, I can use my arrows to distribute against all 4 of these terms. And when I do that, I get -3x minus 6x minus 6x minus 12 plus 27. And then from there, it's just combining like terms. So really, to convert to standard form, that's probably the easiest. Just distribute and combine like terms. This is an example of converting from standard or vertex form into factored form. So right now we're given factored form, and really we can go from factored form into standard form by expanding x minus 1 squared. After we distribute the -2, we get -2x plus 2 times x plus minus 1 plus 18. Now I can use my arrows to distribute between all of those terms, and I get -2x squared plus 2x plus 2x minus 2 plus 18 again. Now I can combine like terms to get -2x squared plus 4x plus 16. Now, what I want to do, since I'm converting to factored form, is factor out any common values that are in all terms, and that'd be -2. Notice that when I do that, my lead coefficient becomes 1 after I factor out that -2. And now what's inside the parentheses is what I'm interested in to continue factoring. And in order to help me factor that, I'm going to use an AC table. And my new A and C value are going to be 1 and -8. And those factors have to add to make -2. And I can get that if I combine -4 and 2, which means that since A equals 1, I can jump straight to factored form of x minus 4 times x plus 2, all multiplied by -2. So that's how I would convert to factored form there. In general, when converting from vertex to factored form, you just want to distribute to combine like terms and then use an AC table to determine factors. Then use a box if A equals 1, or you can jump straight to the parentheses like I did, or you can factor by grouping to finish converting. In this problem, we are starting in factored form and want to convert to vertex form. So really, our first step is going to be to get to standard form by distributing that lead coefficient of 4 into that first set of parentheses to give us 4x minus 12. And then we'll use our arrows to distribute to the second set of parentheses to get 4x squared plus 4x, and then minus 12x minus 12. Here we can combine like terms. We get 4x squared minus 8x minus 12. Now what I want to do is factor out from these first two terms the lead coefficient A, which becomes 4 parentheses x squared minus 2x. I'm going to leave some space because I'm going to add my C2, and then outside the parentheses I have minus 12 and minus 4 times whatever that C2's value is going to be. So let's calculate that C2 value. And since we extracted our lead coefficient of 4, we're going to look at what's inside the parentheses to determine our new C2 value. And really we can use b over 2 squared since our lead coefficient of A is 1 inside the parentheses. So this would become -2 over 2 squared, which is -1 squared, which is just 1. So now I can add 1 here, and then I would subtract 1 here. And now it's just a matter of finishing combining like terms. So actually, I don't need to worry about that subtraction on the 1 there because it's accounted for when I did that subtraction. So this trinomial can factor using the pattern x plus b over 2 squared, since this is now a perfect squared. So this becomes 4 parentheses x plus -2 over 2. We saw it was already -1, and we calculated that when we found C2. Square that off, and now we have minus 12 minus 4, which becomes 4 parentheses x minus 1 squared minus 16, which matches what the key says. And really, to think about converting from factored to vertex form, we want to distribute and combine like terms to get into standard form here. And then we want to find C2 using that equation after we factor out our lead coefficient of A. And once we have found C2, we want to add it and subtract it inside the parentheses and then subtract it outside the parentheses with that lead coefficient accounted for. That's going to be important that you configure that. From there, you can factor your trinomial inside the parentheses into a perfect square using the pattern x plus b over 2 squared, and then combine like terms as necessary.